Hello children. In this video, I am going to explain exercise 1.4 question number 1. In this first two bits I have explained in the previous video. Now I am going to explain third and fourth bit. Okay. So we are giving the proof for the irrational numbers, given irrational numbers. Okay. Prove the following are irrational numbers. Already we discussed the types of the irrational numbers here. Okay, now third bit 6 plus root 2. Third bit 6 plus root 2. Right? 6 plus root 2. So in the same way, we will take the contradiction. So first we will assume this is a rational number. Okay. Let us assume the given number 6 plus root 2 is a rational number. So rational number is in the form of p by q, right? So 6 plus root 2 is equal to p by q. So here, by the definition of the rational number, p comma q belongs to integer family. Q should not be equal to 0. The denominator should not be equal to 0. And here p comma q having the HCF 1. That means they both are co-primes. They are not having any common factor. Okay. So now keep this root 2 irrational number on the left hand side and take the other part on the right hand side, which is equal to minus 6. So root 2 is equal to here LCM is a q. So P, and if this is q times q into 6 is a 6q or q6, anything we can write. Now see, after simplification also, we got root 2 is equal to p minus 6q by q. Here p is integer, q is integer, p minus 6q is, you are going to get integer. Q is integer in the denominator. So an integer divided by integer you gives rational number, right? And we know that root 2 is irrational number. So these two can't be equal, right? So root 2 is irrational number and p minus 6q by q is rational number. Could they can be equal? No, irrational can't be to the rational. So this is a contradiction to our assumption. This is contradiction. Addiction to our assumption. Therefore, 6 plus root 2 is an irrational number. That's it. Next question, root 5. Little bit similar to the first question. Okay, root 5. Let's take it on the board. Fourth question. We need to prove that root 5 is a irrational number. Same procedure. Let us assume root 5 is an irrational number. Root 5 is rational number. We will assume. So if it is rational number, it will be in the form of p by q, right? So that is equal to p by q. Give the definition. Since or here p and q are belongs to integer family, q should not be equal to 0 and p comma q is equal to 1. P and Q are having a HCF1. They both are co-primes. Okay. Now, squaring on both sides. If we have an extra term, we will shift that to the right side. When we have a single term, we will square on both sides. Squaring on both sides. So root 5 whole square is equal to P by Q whole square. Square and root get cancelled. 5 is equal to P square by Q square. That means what? 5Q square is equal to P square. 5 into Q square is equal to P square. That means this 5 is dividing P square, right? If I transpose this 5 to the other side, it becomes a Q square is equal to P square by 5. Here, 5 divides P square. If 5 is dividing P square means 5 divides P also, right? By the theorem. We learned before this exercise, we learned one theorem statement, right? So by the theorem, we can say 5 divides P also. So 5 divides P also by theorem. Let's take, we don't know na, this P. So let us assume this P value as a some phi and constant. Let us take P is equal to 5s or 5r something, 5r. Okay, now apply or substitute in equation 1. What do we get? Pi q square is equal to, instead of P, we will put a 5r whole square. 5r whole square means 5 square is 25r square, which is equal to 5q square. 5 ones are 5 5s are. Okay. So what are we getting? Q square is equal to 5r square. If I take this 5 this side, what it happens? It divides the q square. Here, pi divides q square. So, pi divides q also by the theorem. Okay. From 1 and 2, what did you observe? Phi divides P and Q both. Right? From 1 and 2, we say that phi divides P and Q both. But what are P by Q? P by Q are a co-primes. It is not having any common factor according to our definition. But here in this question, P is dividing the 5. Sorry, 5 is dividing the P and 5 is dividing the Q. That means 5 is a common factor for both of them. But according to our definition, this should not have, our rational number should not have any common factor. But what do we get? Finally, we got they have a common factor 5. 5 is a common factor. 5 is common factor of P and Q. So this is contradiction to our assumption. This is contradiction. Reverse to our assumption. Contradiction to our assumption. Therefore, root 5 is an irrational number. So, like this, with the similar kind of steps, With the simple procedure, we can prove the given numbers are irrational. Let's see few other questions in the rest of my videos. Keep watching. Thank you.